Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Friedel-Crafts alkylation requires the generation of a carbocation or carbocation-like electrophile from an alkyl halide in the presence of a Lewis acid, AlCl3. The carbocation then attacks the benzene ring. Moving on to the next step. Evaluate each option for its ability to form a carbocation with AlCl3. A. CH3, 3CCl, tert-butyl chloride AlCl3 readily abstracts Cl to form a stable tertiary carbocation, CH3, 3C+. This carbocation attacks benzene to give tert-butylbenzene. So this will give a Friedel-Crafts product. B. CH2 is equal to CHCH2Cl, allyl chloride AlCl3 abstracts Cl to form an allylic carbocation CH2 is equal to CH2+, resonance stabilized. This carbocation can attack benzene. So this will give a Friedel-Crafts product. C. CH3CH2Cl, ethyl chloride AlCl3 abstracts Cl to form CH3CH2+, ethyl carbocation. This carbocation attacks benzene to give ethylbenzene. So this will give a Friedel-Crafts product. D. CH2 is equal to CHCl, vinyl chloride the carbon bearing the Cl is sp2 hybridase. The CCl bond has partial double bond character due to resonance between the lone pairs on Cl and the pi system. This makes the CCl bond much stronger and harder to cleave. AlCl3 cannot readily abstract Cl to form a vinyl carbocation, CH2 is equal to CH+, because vinyl carbocations are extremely unstable. The positive charge is on an sp2 carbon, which is less able to stabilize positive charge compared to sp3 carbons. Therefore, no carbocation is formed and no Friedel-Crafts alkylation occurs. Moving on to the next step. Why other options fail to be the answer? Options A, B, and C all readily form carbocations, tertiary, allylic, and primary-secondary respectively, that are stable enough to carry out electrophilic aromatic substitution. And for the final step, vinyl chloride, CH2 is equal to CHCl, does not undergo Friedel-Crafts alkylation because it cannot form a stable vinyl carbocation under these conditions. Therefore, the correct answer is D. Therefore, the correct answer is option D.